Hello everybody, and welcome to the next video of the course. This video is an introduction to loops, which is a foundational topic in any programming course. So the big topics of a general programming course are if statements, lists, loops, and functions. So we've now covered two of the four. This is now the third of the four. So this is a big topic. Loops are extremely useful. We will be using them extensively for the rest of the course. So the goal of this video is pretty simple. I just want to motivate the idea of a loop, why they are useful, and then give you some examples. Okay, so here's the motivation for a loop. So sometimes when you're writing a program, you might need a chunk of code to repeat. So here's a task where you might need that. Suppose you want to let the user give you a list of homework scores in order for you to calculate a homework average. So you want the user to give you, say, 15 scores, and you want to then average those scores to give an average homework grade. So a schematic of the task would look like this. Well, initially, right, so the user is going to give you a list of scores, so it makes sense to use a list. Initially, you have no scores because the user hasn't given you any. So initially, there are no homework scores corresponding to an empty list of scores. And then what you want the user to do is populate that list for you. You want the user to give you these scores. So you need a chunk of code that says something like this. As long as the user wants to keep handing you a score, then what do you need to do? You need to grab that score from them. So they want to give you 100% or a 90%, whatever. You grab that from them, and then you throw that score into your homework list, say using this append function from before. Okay, so that's the idea of a loop. This chunk of code right here, grabbing a score from the user and then throwing that score into the homework scores list, that's a chunk of code you just want to keep repeating over and over and over again until the user tells you to stop. And a loop will let you do that. It will let you repeat those two lines of code as long as, in this case, the user wants you to. Okay, so in practice, so Python, it's kind of an Englishy language. There are certainly English words that appear in it, but of course it's also a programming language. It's not literal English. So it's worth thinking about what kind of English corresponds to what kind of Python tool there is. So if in English you say the following thing, if this, then this, right? Otherwise this other thing. If you ever say the word if or else, you're probably talking about the Python if-else, right? That's probably how you would implement whatever you're doing in Python. With a loop, anytime you say something like this, as long as, you'll probably have to use a loop. The other English phrase to watch out for is the word until, right? Do this until I tell you not to, right? So a word like until or an English phrase like as long as will probably require the invocation of a loop in your program. Okay, so that's the idea of a loop. It lets you repeat code over and over again. There are two types of loops in Python, a while loop and a for loop. We'll start with while loops. It's an arbitrary choice. We're going to cover both. They both just sort of have different syntactical uses. There are just some situations where it's sort of aesthetically more pleasing to use a while loop than a for loop and vice versa. So anyway, we're going to cover both. Today we're focusing on while loops. So here is the syntax of a while loop. While. Okay, so you use the actual English word while, and then you put whatever Boolean expression you want here, and then here's the code that you want to have repeated. Okay, so recall a Boolean expression is either true or false. Right? So this statement here is either true or false. As long as that statement is true, this code segment will keep running over and over and over again. So that's how a loop works. You write the code you want to repeat right here, and then you give it some sort of condition under which it will continue to run. And you slap the word while right in front of that, and there's a colon right there. Okay, so let's look at an example. Here's an example. In the code, you could say, I'm going to let x equal 5. Right, so x is 5. Then you can say, hey, while x is bigger than 1, And notice, x bigger than 1 is a Boolean statement that's either true or false, depending on the value of x. And of course, right now, that's true. X is 5, 5 is bigger than 1. Okay, here is some code to repeat over and over again as long as this condition is still met. Okay, so what I'm going to have happen is print x. So it's going to print the value of x to the screen. Oh, and then I'm going to replace the value of x with 1 less than the current value of x. Okay, so x is now going to be x minus 1. So if x was 5, now x is going to be 5 minus 1, which is 4. So let's think about what happens here. X is 5, right? That statement is true. So I'm going to do this code down here. If, by the way, x were negative 1 or x were negative 5, whatever, the statement is not true. So you don't do this code at all. You just skip over it. The same way you skip over chunks of like an if, else if sort of structure if things are false, right? So the fact that x is actually bigger than 1 initially means you actually sort of go into the loop. You will do this code. Okay, so x is 5. 5 is bigger than 1. That's true. So I'm going to print x. So I will print 5. Then x becomes 1 less than its current value. So x becomes 4. Then what the code does is it jumps back up to the top of the loop and checks whether or not this condition is still true. So the code loops on itself, right? So you do this stuff in a linear fashion. You do this, then you do this. Once you're done with this, you loop back up, check if this condition is still true. If the condition is still true, then you do this code over again. If this condition is now false, then the loop is now done. You do what is called breaking out of the loop. So if this is false right here, then you just exit the loop and you start up whatever code is down here at the end of the loop. So this indented stuff right here is all inside the loop. Once this condition is false, you break out and the loop is done. Okay, so 5 became 4. X now has value 4. 4 is bigger than 1, so you print x, which now has value 4. You decrease the value of x to 3, and then jump back up. 3 is bigger than 1. That's still true. Print 3. X then becomes 2. 2 is bigger than 1. Print 2. But now finally, when x is 2, then the new value of x is 1. 1 is not bigger than 1, right? This statement is now false. As soon as the statement becomes false, when you check it, right, so you get to the end of the loop and you check, oh, well, 1 is bigger than 1 false, and I'm done. So that code prints these values, 5, 4, 3, 2, 1. And then you break out of the loop. Just as an aside here, this command x equals x minus 1 can be shortened to this, which I don't actually know is shorter, right? But whatever, you'll see this in code a lot. Instead of writing x equals, they just do plus equals negative 1. That knocks 1 off of x. Similarly, if you want to increase x by 1, you can do it like this. X equals x plus 1 can be shortened to x plus equal 1. So you'll see these sort of commands in other people's code instead of x equals x plus 1, or, x equals x plus 3. You can just write x plus equal 3. So anyway, here is our first example of a loop. This code segment just repeats over and over and over again as long as this condition is true. If I reach the bottom of this code here, this indented code, I reach the bottom, I then jump up and check. If this condition is now false, then the loop is over. I don't do it anymore. Okay, here's another example. So number equals input. How many times do you want me to greet you? So basically you're going to say hi to the user a bunch of times and they get to decide how many times that is. So suppose they want to be greeted 5 times, right? This number becomes 5. Well, while, or as long as, if you want to translate it into English, as long as that number is bigger than 0, you're going to greet them. Hey there, champ, And then what you're going to do is decrease the value of number by 1. So if the user enters 5, then after the first run through the loop, this is now 4. Well, 4 is bigger than 0, so I'll do this again, decrease down to 3. 3 is bigger than 0, print this again, etc. So if the user enters 5, this loop will run 5 times. 5 is the initial value of number, then you get to 4, 3, 2, 1. Number will eventually reach 0. 0 is not bigger than 0, right? This becomes false, so you break out. Okay, so however many times the user tells you to greet them, this will greet them. Here's an example of what we did, or we talked about as the motivation. So let's talk about how you could grab a bunch of scores from the user where you don't know how many scores they will give you. You know, the user may only have 5 homework scores, they may have 30 homework scores, whatever. Okay, so initially you have an empty homework list, you have no scores from them. Then you tell them, hey, give me as many homework scores as you want, enter a negative number when you're done. Okay, so presumably nobody is scoring negatives on homework, right? Hopefully that is the case. Okay, so what I'm going to do is I'm going to set up a while loop using what's called a dummy variable x. X here only exists to give me a way to break out of the loop, to make the loop stop. Okay, so this is a cute little technique you can use. If you ever just want to introduce a way, like a quick and dirty way of breaking out of a loop, sometimes you can create a dummy variable whose only existence or purpose for existing is to break out of a loop. Okay, so x is 0, right? Well, as long as x is 0, do some stuff. So since x is 0, I go into this loop because this statement is true. And then I say number equals int input score. Okay, so they're going to give me a homework score, right? Well, if the number they gave me is 0 or bigger, in other words, it's not negative, right? What happens? Oh, well, then you throw that number into the homework score list, right? So if the user enters a 7, well, that gets thrown as a 7, right? And then what happens? If the number they gave you was 0 or bigger, then you do this part of the if. You don't even see this else, right? Because you can only do one branch of an if-else. Now you're at the end of the loop. So you come back up and you check. Is x still 0? Well, yes, it is, right? Because if the user gave you a score that was 0 or bigger, you didn't change the value of x. All you did was throw a number into the homework score list, right? So if the user entered 7, then that 7 gets thrown in. The loop is now done, or the code in the loop is now done. So you jump back up and check. X is still 0. So then this just repeats. Number equals input score, right? So now they can give you not a 7, a 30 or something, right? Well, 30 is bigger than or equal to 0. So you throw that 30 into the homework scores list. You don't even see this else. The loop code is now over, so you jump back up. Oh, well, x is still 0. The value of x didn't change, right? But suppose now they enter a negative 5, right? So when I give them this command of input score, they enter a negative 5. Well, negative 5, right, is not bigger than or equal to 0. Negative 5 is negative. So I don't do this if, which means I have to do this else. And you see what happens in the else? The value of x changes to something not 0. So I could have put any number here, 5, 30, whatever. But as soon as the value of x is not 0, right, well, this condition is false. So you break out of the loop. The loop is now done, okay? So here's sort of a, I don't know, quick and dirty way, cheap and dirty way, perhaps you might say. This is not particularly elegant, but it's a nice little trick. Here's a trick for getting the user to input, say, like a bunch of exam scores to you, or homework scores, or quiz scores, right? A bunch of positive numbers to you, and you can make the loop stop by commanding the user to give you something negative when they're done. Right, so they'll give you their 10 homework scores and then enter a negative 30 to break out of that. So there's another example of a loop. Okay, also, this is a different way of making that loop break out. So I come from the world of C++, where you would see things more like this. You'll see this in Python sometimes. But in Python, you're more likely to see this. This will do the exact same things for you. So homework scores equals empty. Yeah, blah, blah, it's the same. But now notice I just say while true, just the Boolean statement true. Well, the Boolean statement true is always true by definition, right? So this loop will run. And then you do the same thing, get a score from them. If that number is bigger or equal to 0, throw it in there, right? What if that number is negative? Notice here I have a simple command here called break. So this break statement, anytime you reach that inside of a loop, the loop just dies. So this is a loop termination command, okay? So even though this statement is always true, like true is always true, okay? Inside of this while loop, if you ever encounter a break statement, the loop ends. So here's an equivalent way to do the same task, right? This loop and this loop will do the same thing for you. Again, C++ people are less likely to use a break statement for whatever reason, I don't know. than Python people, so you'll see this loop implemented either way, with this sort of dummy variable x, or with just this hammer, right? This break statement is just a smashing through the loop hammer. Okay, so once you have the homework scores, how would you calculate an average, right? So the motivating example we had was getting scores from a user and then telling them a homework average. We now have the scores. How do you get an average? Well, you got to add up all the scores and divide by the number of scores, right? You just compute an average the way you think you should. So the question is, well, how do you get the computer to add up all the scores and then divide by the number of scores? What does that look like? Okay, so it looks like this. So you create a variable that I'm going to call sum of scores. And that sum is 0 right now because I haven't added any scores to it, right? And I'm going to create this, this variable x here that's basically just going to be a counter variable or an index variable. It's just going to let me go through the list of homework scores and just record what my score is. So let's just look at the structure of this loop. As long as x is less than the length of the list of homework scores, right? So recall, homework scores is a list. It's a list whose elements consist of individual scores on homework assignments, right? So if you have 10 homework assignments, this length is 10. If you have 20 homework assignments, this length is 20, right? Okay, so anyway, as long as x is less than the length of the homework scores, notice this command here. Sum of scores is going to be plus equal homework scores at position x. Okay, so what's happening here? Well, x is 0, right? So initially I'm saying homework scores at position 0, add that to sum of scores. Right, so sum of scores started off at 0, and then I add to it the first homework score. Okay, so suppose my first homework score was 20, whatever, right? Then when x is 0, homework scores at position 0, that is 20. So you're adding 20 to the sum of scores right here. So after the first pass through of this loop, sum of scores is no longer 0. It's 0 plus whatever that first homework score was. Okay, now, for some reason it's not showing up on my slide, though it's in my code. So if you think about what should happen next, right? You've taken the homework score at position 0 and added it to your sum. Well, now you got to advance, right? Now you need to add the next homework score and then the next homework score, right? So what's missing from this code is just add an additional line if you're playing with this in your compiler and write the following thing, x plus equal 1. Okay, so what's missing here is x needs to advance through the list of homework scores. X starts at position 0 in the list. You then need x to become 1, x to become 2, etc. You need to iterate your way all through the homework assignment scores that you have. So again, I'm not sure why this isn't showing up here, but there should be a line after this line here, after this one, that says x plus equal 1. Okay, so here's a list, or a loop, sorry, that lets you just add up all the elements of a list. You add the score position 0, then move on and add the score position 1, add the score position 2, etc. And you keep going as long as this x value hasn't reached the end of the list yet. Okay, the end of the list occurs at the list's length. All right, so if there are 10 homework scores, recall that the positions run from 0 to 9, right? So once you reach position 10, you got to stop or you've gone too far. So with the command, again, that's missing from the slide, a command after this that says x plus equal 1, x will start at 0, then become 1, 2, 3. It will reach 9. Once it reaches 10, the loop is done. And then you can just ask the computer to print to you that sum you got. And recall, again, length of homework scores, that's the number of homework assignments you had. That's the number of scores you have to divide by. Okay, so all that to say, this example is showing you a loop can be used to add things together if you want to. A loop can be used to add together all the elements of a list where, again, I'm sorry this is missing, but you need this x plus equal 1 command in here to make x advance through the list. Okay, so let me conclude this video with a warning, and this slide actually illustrates this warning quite nicely, but beware infinite loops. Okay, an infinite loop is a loop that goes forever. And that's bad because generally speaking, you want you wrote your program to do something for you, right? To compute something for you, to display some information for you, whatever. If you create a loop that never ends, then the program never ends, and you never get what you want from the program. So here's an example of an infinite loop. So x equals 5. As long as x is bigger than 1, print x. Okay, so many of you can probably see what's going to happen here, but you may want to copy and paste this into your compiler or type it into your compiler and see what happens. So if you just talk through what happens, right? 5 is bigger than 1, so you print 5. Okay, so well now the code inside the loop is done, so you jump back up to the beginning and see if this is still true. Well, 5 is still bigger than 1, so you print 5. Jump back up, check if it's true. 5 bigger than 1, so print 5. Jump back up, check still true. There's no way for this condition to become false. Right? This condition just stays true. So what's missing here, similar to the previous slide, what's missing here is some sort of change in x inside the loop to make this loop stop running. So presumably whoever typed this, which was me, right, as this example, but in practice whoever typed this has forgotten a command that looks like x plus equal -1 right here. Right, whoever set this up probably meant for x to be decreasing inside the loop so that you'll eventually break this condition and leave the loop. Okay, so anyway, so for people who aren't used to loops, this is a common error, to set up a loop that you think is doing what you want. And in this case, printing the value of x is maybe what you want, right? But you set it up and you forget to give the loop a way of exiting, which means that your loop just runs forever. And by the way, again, I don't know why the line is missing for me here, but notice this is an infinite loop that I set up here. Right? So without that command, x plus equal 1, the value of x never changes inside this loop. Right? The value of x just stays at 0. I never changed it. So this loop will also run forever. Right? This loop is just going to run forever. I'm just going to keep adding and adding over and over again the first homework score to itself, because the value of x is going to be 0 no matter what. But notice, if I have that command x plus equal 1 down here, you're changing the value of x, allowing x to advance itself through the homework score list, and eventually x will become big enough that you break this condition and therefore the loop stops, and then you can get your homework average. Okay, so again, this is something to be aware of. You need to really give your loop a way to stop, because presumably you want your loops to stop. Okay, that's the end of this video.